Hello, welcome to FX PhD. My name is Matt Leonard and this is class number 1 of arn201 Real-World Lighting and Rendering. So in this class we're going to be looking at a whole host of things, starting off with a bit of history on Solid Angle, the company that makes Arnold, and the Arnold renderer obviously itself. We're going to be looking briefly at physically plausible rendering and just what that means and why is it important to this particular course. We're going to be looking at scene-referred linear workflow, and then we're going to be moving from there into a mini project that's really going to get us up and running in Arnold, enabling us to add some textures, some lights, and get a render out all in class 1. So let's begin by looking at the history of Solid Angle and Arnold. So let's begin by looking at what Arnold is. Well, obviously it's a renderer, that's a given, everyone knows that, but it's a physically accurate renderer, and that means that it physically accurately simulates lights and shaders, and that's what we're going to be talking about when we're going to be looking at physically plausible rendering in a moment. Also, it offers full ray tracing and global illumination solutions, and what that basically means in a very broad sense is that you can't shut them off. Basically, ray tracing and global illumination is always on, unlike something like RenderMan or Mental Ray where you can switch ray tracing on and off or global illumination on and off. In Arnold, they're just on, and that's how it works. And that's very important to the way that Arnold works. Also, Arnold uses Monte Carlo path tracing techniques. Now that's a bit of a mouthful and can become very complicated, but what you need to know is that it's a system or a method of ray tracing. Okay, so that's all that's important. Though when people talk about Arnold, this Monte Carlo path tracing obviously often comes up in the description. Also, Arnold is very good at dealing with very large geometry caches, and we've seen that in films such as Gravity, Pacific Rim and Elysium, where we've literally had hundreds of millions of polygons on the screen being rendered and just looking fantastic and going through the system very quickly. Finally, we have a very simplified user interface, and this makes Arnold very quick to learn and, more importantly, very quick to use. So with other render engines, maybe something like Mental Ray for instance, where you have to fiddle with what seems to be a huge number of different controls to get the render to look nice, with Arnold you really only have a few sliders that you operate and you get your image looking pretty good very quickly. So from there, let's talk about what is Arnold actually for, or what does it interface with? Well, Arnold works with Maya, which is obviously what our entire course is going to be based on pretty much. It also works with Autodesk Softimage. You can get Arnold for Katana, and if you did my Katana course a few terms back, you'd have seen that I was using Arnold a lot for that. And also Arnold is being used for Houdini, and that's currently in a kind of an alpha or beta stage at the moment. Finally, you can have Arnold just as a standalone program, and that again can be very useful if you need it. Now the question that you may be asking is, well, who's actually using Arnold? We've obviously heard about it, there's been a lot of press, a lot of buzz going on about Arnold, but who's actually out there using it? Well, this is just a very small sampling of some of the companies that are using Arnold, and you can quickly see that the big names are here. We've got people like Industrial Light and Magic, Digital Domain, Frame Store, Moving Picture Company, MPC, obviously, Prime Focus, Sony Picture Imageworks, the Embassy, the Mill, and also companies like Glassworks in the UK, Image Engine in Canada, Luma Pictures, Method Studios. All the big names are here, and pretty much everyone that I've heard of is either using Arnold or betaing it at the moment, looking to move on to it hopefully in the future. Now, with all these companies using it, have you been seeing Arnold? Well, obviously you have, because there's been a huge number of films coming out with Arnold renders in them. So firstly, let's just have a look at the last year, 2013. Well, obviously we've got Gravity. Gravity was huge. All of the rendering in Gravity was done using Arnold. We've also seen it, as we've said, in Pacific Rim, in Elysium. We've seen Arnold in Star Trek, 47 Ronin, Hunger Games, Jack the Giant Slayer, Lone Ranger, Smurfs, a whole host of films as you can see here. And going back in time, we've again got Arnold all over the place. Avengers, for instance, The Amazing Spider-Man, Men in Black 3, Source Code, Thor, Arthur Christmas, Mission Impossible. And then going back even further, we've seen it in things like Alice in Wonderland, Watchmen, Monster House, etc. Now, coming up in this year, 2014, again, Arnold is going to be all over the place. RoboCop, which is opening very soon. Jupiter Ascending, All You Need Is Kill, the new Tom Cruise movie coming out. Guardians of the Galaxy, Spider-Man 2, and a host of other movies as the year goes on. And this is just a small selection of ones that I know about and that we can talk about, though there's obviously going to be countless others as we go into the year. So really, Arnold is being used all over the place, which is fantastic. Now, what are the origins of Arnold? Where does it come from? Because it feels like it's only just that people beginning to talk about it over the last few years. Well, Arnold has actually been around since 1997, and the lead architect of Arnold is a gentleman called Marcus Fajardo. Now, in 2004, Marcus joined Sony Picture Imageworks, and he worked alongside Imageworks engineers, continuing to develop Arnold. And what happened that was very interesting, in 2009, Sony Picture Imageworks moved from Pixar RenderMan across to be 100% Arnold House. So this was one of the first major, huge visual effects companies basically moving from a very solid, very well-renowned render engine across to Arnold. And since then, they've remained 100% Arnold ever since. Now, in 2009, Marcus left Sony Picture Imageworks and he founded Solid Angle, which is where you'll now find him. And Solid Angle continued to develop Arnold, and it's obviously through Solid Angle that we now can get Arnold, and all the development continues from there in Spain. Now, from here, let's look at physically plausible rendering and just very quickly talk about what this actually means. Firstly, physically plausible rendering means that the shaders are energy conserving. And what this basically means is that the shaders shouldn't reflect more energy than the light is outputting. So if the light's outputting a set value, we shouldn't be able to reflect more information off the shader than it's actually receiving. So that's a very important concept. Also, the shaders are based on real-world physics, and what this means is that the microfacet distribution of diffuse specular reflection, things like that, are weighted by a Fresnel coefficients, or BRDFs. So that then gives you a very real kind of physical structure to the actual shaders themselves. Now, from shaders to lights, the light should have a physical size. So there's a strong use of things like area lights or other lights that can actually have a physical size attached to them. And that doesn't mean you can't use point lights or spotlights where you've got a incorrect size or kind of a size of 0. That is possible still to do, but if you're doing that, you're going to be breaking this physically plausible working relationship with your shaders and things like that. So it is possible, though it isn't advisable if you're trying to keep everything physically accurate. Now finally, we have multiple importance sampling, or MIS, and this is used to reduce noise and focus on just the important areas in the scene to sample. So MIS, or importance sampling, is one of the key things again in getting a physically accurate render system. So what does it look like if your system isn't physically plausible? Well, let's go into Maya and have a look at an example of that. Okay, here we are in Maya 2014. I'm just going to go ahead and load our first scene, which is this PPR01. So I'm just going to open up this. And what we're going to do is we're going to first look at how you can actually break a system or have a system that isn't physically plausible and the problems that you can run into. Now we're going to do this using Mental Ray, and we're not doing it in Mental Ray because we have a downer on Mental Ray. Obviously it's a fine renderer, though it has many controls that need to be adjusted. We're doing this because basically in Arnold it's very difficult to break it out of this physically based system, and Mental Ray is a much easier way of doing it. So here we have the Stanford Bunny, and I have textured it using a basic Blinn shader. So this is based off of James Blinn's work, and you can see if we come into our render settings, we have our quality set to 0.75, and we have indirect lighting just off at the moment. So if I do a render of this, what we're obviously going to see is Maya making its default light and the render that we're going to get from that. So we'll just let that go through. You can see it now appearing here. Now we've obviously switched on ray tracing. If I come over here and come to quality and scoot down, you can see here's ray tracing, and I can switch it on and off. That's obviously again something we can't do in Arnold. It's just always on, which is fantastic because we want it on all the time. And what we can see is we've got our rabbit here. So what we're going to do is we're actually going to use a high dynamic range image. So I'm going to come across to the image-based lighting. I'm going to hit create, and up over here you can see I can now choose the file I'm going to go with. So I'm going to come across to my folder HDRI, and in here we have 3 files that I've made. We have a image here that has 16 stops of latitude, we have an unclamped file, and we have a clamped file. Now what do these actually look like? Well, let's go into Nuke just so you can quickly see how dynamic these images actually are. Okay, here we are inside of Nuke 8.0. This is my kind of color correction setup, and you can see that I've loaded in 3 images here. We've got our clamped image that's clamped to a value of 0 to 1. We have this image which is clamped to 64,000, which is around 16 stops, and then we have my unclamped version here. So let me just put my viewer on the unclamped one, and you can see this is the image we're going to be looking at. This is of Tintin Abbey, and you can see up here we have the sun, and this is the brightest spot in our image. So we're just going to zoom into this section of the image. And you can see as I move my mouse around, you can see that we're getting extremely high values. There in the red channel, we've got 75,000. That's 93,000. And if I go directly into the center of it, you can see we've now gone above 100,000 in the red channel, green channel, and blue channel. So this is a very wide high dynamic range image that we've got here. The next one is one that I've clamped to 16 stops, and that basically means that when we move our mouse around here, you can see that we're getting a maximum value of 64,000 in the red, green and blue. So that's been clamped to around that, which gives us about 16 stops latitude. And then if I move to this image, this one is clamped, and so you can see we literally have a maximum value of 1. So this really is like an 8-bit image. Okay, so these are the 3 images that we're going to be looking at. We're going to first of all apply this unclamped image onto our bunny as the HDR lighting setup. Okay, so there's the image that we're going to be using. Let's just return to Maya. So here's Maya, here's our image. This is our image-based lighting that we've created here, and I'm going to put into that, again, if we just move back to our HDR folder, our unclamped image here. So we're going to go with unclamped. I'm going to turn on final gathering, which is basically like global illumination. And global illumination here, if you're not used to mental array, this is basically a photon system where it shoots out photons if you put on global illumination. So final gathering kind of works more like normal global illumination does on things like Arnold or V-Ray or RenderMan. So I'm going to put this on. You can see that I've got some pretty good settings here. Accuracy 250, which is up from 100. Point density at 2. Point interpolation at 20, which again is up from the default. And I've also added 1 set of secondary diffuse bounces. So these are pretty good, reasonably high settings. Okay, so we would expect this to give us some nice results. Remember, however, that we're using Mr. Blin's shaders here, which are not physically accurate. So I'm just going to go ahead and hit the render, and I'm going to pause the lesson while this runs through. Okay, so that's just finished. That took 1 minute 32 seconds, and you can see that we've basically got all these dots that have appeared everywhere. Now the only way that we can really get rid of these is to crank up some of our settings in our renderer to give us much higher results. But unfortunately doing that is going to really mean that this render time is just going to go through the roof. So it's really not practical to do that. So what people tend to do in this situation is that they basically use a HDR that isn't so high dynamic range. So what we're going to do is we're going to go with our clamped version. And remember, this is now just like a standard 8-bit image. So I'm just going to come in and I'm going to turn off the background just so we don't see the image by going to primary visibility off. Let's focus on a section of our bunny here, and again now just re-render. Now remember, everything else is the same. What we've done is just take our image and we're just using now what in effect is an 8-bit image, or a clamped 0 to 1 image. And what you can see now as it renders is that we're really not seeing any of those spots appearing. So let me just wait again. I'll pause the class while this renders through. Okay, so that's just finishing up now, and you can see at 1 minute 9 seconds we've now got a really nice image, everything you would expect. However, because we're now using this clamped HDR, we're no longer creating a physically accurate image, because we're not using physically accurate lighting anymore to actually illuminate this scene. Okay, so that's the problem. Now it's worth noting, just so people who are using Mental Ray don't have a fit and send me hate mail, that Mental Ray does have the ability to actually use physically based shaders. Let me just show you where that is. So if you just come to your hyper shader here and you come across to our Mental Ray materials and we look at something like the MIA Material X, this is actually a physically based shader. So using something like that will enable you to render with a much higher high dynamic range image, but using something like our Blinn 1 doesn't. Okay, so I'm just highlighting that just so people that use Mental Ray don't think I don't know what I'm talking about. Now let's move across to Arnold. So I'm going to open up our other scene. This is our Arnold scene. We're not going to bother saving that. Now I've tried to get the shader to look roughly the same, though obviously we're using an entirely different render engine, so it's not going to be exactly the same. So if we click on our bunny, let's just have a look at what shader we're using here. So here I'm using the standard AI shader. This is the AI standard, which is kind of the main one that you're going to use for most of the work. And you can see there's a whole host of things we can do in here, but the important thing to note is that this is a physically plausible shader. I'm also just going to come into the render settings, and you can see that this is set to Arnold, and I'm going to come up to my Arnold menu here. I'm going to come to lights, and I'm going to choose a sky dome light, and then in here I've got my color. I'm going to open up this, and I'm going to choose from my menu here of Arnold textures an AI image, and then into my image I'm going to choose first off my high dynamic range image. That is the unclipped one that caused all the problems in Mental Ray. Okay, now other than that I'm going to leave pretty much everything else the same. I'm not going to make any adjustments there, and we're going to come across and hit render. Okay, so there's Arnold finished rendering. Took about 1 minute 26 seconds, so very similar to Mental Ray with the settings that I have. And you can see that we're now getting a really nice image without any of those kind of light spots that we were seeing before. And this is, as I said, is because Arnold is doing this physically based, physically accurately. Even though we're using that very high dynamic range image, we're not getting any of the spots we were seeing before. Okay, from here let's go back to our presentation. Okay, next up we want to look at scene referred linear workflow. Now what does this mean? Well, this is how do we deal with different types of images. Some images are linear, some images are sRGB, some images have come from Cineon, some have come from the Red Camera, some have come from Panavision, Arri Alexa. How do we deal with all these different types of images? And more importantly, for our rendering, how do we deal with the difference between an sRGB image coming in and also a linear image coming in, and how do we deal with displaying it, because we have an inherent issue with our display systems that we're using. In fact, the very display system you're watching this video on has an inbuilt problem with it, which we're going to look at. So first off, we have our monitors. Now this could be an old CRT screen which was physically impaired, or the new LCDs, which are obviously your iPad, your flat screen monitors, your iPhones, whatever you may be using. And these all have the problem that they actually darken the image that you're looking at. And in the old days when CRT was invented, this was kind of an inbuilt hardware issue. But when flat screens came out, they decided that they were going to keep that system, keep it darkening the image, only because if they made such a massive change that the monitor actually displayed the image properly, we would find all the existing images that had been made for CRT monitors would then be incorrect. So the LCDs actually darken it purposely so that everything remains the same from the old CRT days. But basically what's happening is that the monitor is changing the gamma by a value of 0.4545, which is darkening the image. Now this is what we called sRGB gamma. Now on the left hand side you can see the original image there as it's intended, as we perceive it to be in our mind that we want it to look like. When we take that image and we display it, we're actually then seeing it dark, and that is obviously because of this gamma issue that we have. Okay, here's just a quick diagram showing what's actually going on with the gamma. So gamma is a power function. Basically you can see if a gamma value is 1, it returns the same value. If you increase the gamma value beyond 1, the pixels get brighter, and if you drop the gamma down beyond 1, it gets darker. So that's just what's happening with our gamma curve. Now, gamma 2.2 or sRGB is basically burnt in physically to the file at the point in which it's saved from either Maya, Nuke, Photoshop, whatever application you're using. It's actually physically burnt into the file, and any file that's 8-bit or 16 that's saved as something like a Targa, a JPEG, PNG, bitmap, anything like that is basically encoded or having this gamma correction burnt in. And what it's obviously doing is having a 2.2 gamma that's brightening the image, and therefore the image is actually physically going to look brighter than it really is. But again, remember when we display it on our monitors, it then looks correct. Now this can obviously be a problem if we're dealing with a system that may expect the image not to have a 2.2 gamma, or if we give it a file that hasn't got 2.2 gamma correction burnt in. So we've looked at the files that will have it burnt in. What won't have it? Well, one of the key file formats that doesn't have gamma burnt in and remains linear is ILM's OpenEXR format. Now, any classes that you've probably done from myself, Tile, any of the other guys here at PhD, everyone is probably advocating that you use this file system. And one of the key reasons that we like the OpenEXR file system is because it is linear. It doesn't have this gamma correction burnt in, which means that you're kind of getting what you expect and you don't have to do any changes in order to work with it. Now, one thing to note, which we haven't talked about at this point, is all of our software basically works at a gamma value of 1. And if you don't have gamma at 1 internally inside of Nuke, inside of Maya, inside of Arnold, RenderMan, whatever you're using, Photoshop, etc., you're basically going to find that all the maths that you're doing in doing your compositing operations, etc., are all going to be done incorrectly because you're not working on a linear system. And that's why it's very important that everything is linearized. So what tends to happen is you have a file that is, say, a JPEG file that you're going to bring in to Maya. And what Maya needs to do is it needs to convert that file from an sRGB gamma or a 2.2 gamma back to linear. And once it's linear, it then works with it internally. And then when it renders it out, it then needs to do more gamma corrections in order for us to see it correctly. Now, inside of Arnold, the good news is that all this is taken care of automatically for us. So this little screen that you see here is our gamma correction inside of Arnold. And you can see that we have these 4 sections. Display driver gamma, which is basically your monitor. The gamma correction for your lights, shaders, and textures. And basically what's happening is Arnold is saying that the display driver is needing to be gamma corrected to 2.2. So we're basically, as we render from a linear inside of Arnold, inside of Maya, it's then lightening the image so that when you see it displayed on your viewer, it looks correct, or your render view. It's also making changes to our lights, our shaders and also our textures. So any textures that have been rendered as 8-bit or 16-bit, they again are having a gamma correction so they appear correct. So we're basically changing the gamma so that they become linearized, our JPEGs, our TIFFs, etc., so that they then work correctly inside of Arnold. So let me just very quickly show you how this works. So again, here's our rabbit. I haven't changed anything since we last looked at it. I'm going to open up my render settings and I'm going to come down to our gamma correction. Now, what this is doing is it's saying because we're viewing it on a monitor, we want to take the gamma from linear to 2.2, brightening it so the physical monitor that darkens it then makes the image look correct. If I put this back to 1, where we now have a linear image, and I just turn my render settings down just a little bit so that we're going to get a quicker render, just so you can see. I do the IPR. You can see straight away we're getting a darker image, and this is literally because this is now what linear looks like displayed on a monitor that is darkening it. Okay, so we need this set to 2.2, which it is out of the box. The minute I do that and we just hit render again just to refresh it, you can now see we're getting the correct values. Now, if you're used to using Mental Ray's linear system, we can also use that here. So I could come into my display driver and set this to 1. And let me just close this for a moment. I can then, in fact, reopen this, come into display and come to color management. And that opens it here. And you can see what we're getting here is the image color profile and the display color profile. So the display color profile is our monitor, which needs to be sRGB, but the image color profile, this is basically what is the internals of our system using. Now we know it's using linear, everything uses linear internally, so we set it to linear, and you can see now when I re-render this, we're then getting exactly the same look if we had left that at sRGB, but instead, if I just move this over, but instead had this set to 2.2. So there's two different ways of doing it. They both result in exactly the same look. So that is how we deal with our gamma correction in Arnold. The good news is it's set up completely correctly out of the box, so we never need to worry about it. Okay, so if we just briefly return to Keynote, from here, having got our heads around linear workflow, plausible lighting and rendering, and just the history and background of Arnold, let's actually get in and do a very quick mini project. And this is going to involve us adding some shaders to some objects, some lights, and just rendering it, and then we'll be done for this week. So again, let's move back over to Maya to do this. Okay, so what we're going to do now, having looked at all of the other areas, we're going to now move across to our mini project. And in this, we're going to basically go through all the things that you would normally do in an Arnold renderer, or the kind of the main things you'd look to do, which is basically work with lights, shaders and textures, render settings, and then obviously render something out. So it's going to be a very kind of whistle-stop tour, but at the end of it, we will have something textured, lit, and rendered so that you can immediately begin to get on and play yourself and know how everything works. So I'm going to use a scene which is the fish tank scene. So I'm just going to open up here. Our mini project I'm going to bring in. This is the scene, and this is based off of a solid angle tutorial. So if I just hit render, what we're going to see here is the Maya software render just kicking in, and this is what we're getting. We have a default Lambert shader applied to everything. So the first thing we're going to do is we are going to switch across to Arnold. So I'm just going to come across to our Arnold render here. I'm also just going to change the render size just to speed things up. So I'm going to come across to our common section, and I'm going to change it from 960 to maybe 600 by 338, which is about the same aspect ratio as 16 by 9. Okay. Other than that, I'm going to leave everything default for the time being. And when I say default, what I've actually done is I've just made all of my sample settings and my ray depth settings equal 1. Okay, and as we go through and we hit different situations, we will be increasing these and just roughly saying what we're doing in increasing them as we go through and need it to be done. So first off, we want this bowl to be a lot smoother. So I'm going to press 3 on the keyboard, having selected the wireframe, and that basically switches the wireframe into smooth mesh preview mode. Now, if you want to kind of change this so that it then becomes a polygon again, you could do by going to modify, convert smooth mesh preview to poly. But like Mental Ray, Arnold is able to render this. So if we come across to Arnold and I just hit render, what you're going to see is that now rendered. But interestingly, what you will see initially in the RGB channel, the color channel, will actually be nothing. So here it comes. You can see it renders really quickly, but we actually have nothing there. Now, the reason why you're not seeing anything in the view is really because we have no lights. Now, what you're probably familiar with is if you're using the Maya software render like we just did, we get something illuminated. We get our scene illuminated even though we don't have any lights kind of visible or made in the scene itself. And that's because what the Maya software render does is it basically throws in a kind of a pseudo light while it's rendering and then deletes it at the end. But at least you then get your scene illuminated. Inside of Arnold, however, that doesn't work. You actually need to add a light, which will be the first thing we'll do. However, if I check the alpha channel, you can clearly see that we actually do have something, and that smooth poly is actually getting generated correctly. So pretty happy with that. So let's go back to RGB. And let's begin by using an image-based light to light our scene. So I'm going to come across to the Arnold menu. I'm going to come to lights and I'm going to choose Sky Dome Light. And this is the same as using an image-based lighting system inside of Mental Ray. So I'm going to click that. You can see, as before, we get a big sphere around our object. I'm going to come across to the attribute editor. We're going to choose the color. I'm going to click on the little texture swatch. And in here, if I wanted to, I could use file, but what I would tend to recommend is going to the Arnold texture. We'll hide the rest of them. Go to the texture here, and we want to choose the AI image. So I'm going to choose that, and we now have that dropped in, and we can now say the image name is, and I'm going to come across to my HDR folder. And I'm going to go with the unclamped version. This is the one where the highlight in red, green and blue was about 100,000, so incredibly high dynamic range image. But as we know, everything in Arnold is physically plausible for the most part, and so we're happy to use this knowing that we're going to get great results. Going to load that in, so that's done, and I'm going to hit render again, and what we'll now see is our scene illuminated. Okay, so there it is. It went through very quickly, only 4 seconds to render. What you will, however, notice is it is very noisy. Now, really, with Arnold, this noise is the only thing we need to contend with. It's the only thing that we need to adjust and manage, where with other renderers, there's many other things that you need to tweak around to try and get it to give you a good result. With Arnold, we just have to deal with the noise, which is very straightforward because it's all sample-based. And you can see at the bottom, tells us what our samples are. We've basically got everything set at 1 at the moment, okay, and that's why this is noisy. It wouldn't be unusual to have some of these at values such as 6 or 5 or 4 or even higher in some occasions. So 1 is really kind of the lowest quality, but it gets you a very quick render, and you can see even with this noise, it's very, very easy to see what's going on. So let's just click on here. We're now going to come across to our channel box, and we're just going to close up some of this so we can focus on certain areas as we go through. So firstly, we have our table. Let's get some texture assigned to that. So I'm going to come up to my window, render editors and my hypershader. Let's open that and move that across to one side. So I'm just going to move that across here. I'm going to only look at the top section. And I'm going to press F in the view just to make sure they're all framed up with which they are. I'm going to grab my floor here. And you can see I've labelled everything quite nicely here, so it's very easy for us to apply things. So this table section that we have, I'm just going to take the shader, and just like you would in Maya normally, I can drag it to it with the middle mouse button. I can select it, and in the view here, right click, and it's actually off the bottom, but I can go with the assign existing material, or if I want, I can just, with the table selected here, right click on the table texture and just say assign material to the selection, which is what I'm going to do for most of this. Now, to help me out even more, I'm going to open up my outliner, because again everything is labeled up quite nicely in here. Okay, so this is the table, and I'll just name that correctly there. So let's now hide the table. Let's open up the fish, and the fish consists of three main parts: the fish body, the fish eye, and the fish pupil. And again, if I open up the fish tank, open up the fish, you can see that I've got pupil, left and right eye, and the body here. So I'm going to grab the body and come to fish body. Let's assign that. I'm going to go to the left and right eye, and I'm going to assign fish eyes to that. And then I'm going to go to the pupil, and I'm going to assign the fish pupil to that. Now, just so you can see what this is going to look like, I'm going to frame in on it, and again just hit the render button just so you can see what the fish is looking like. Okay, so again, really quick 3-second render. We've got subsurface scattering going on there, lots of really nice things, and we're getting a great render, though it is obviously noisy still. So let's hide the fish and just go through this very quickly, assigning everything we need to. So next up, we've got the fish tank, and this consists of water within it. So I'm going to select the water, right click and assign the water there. Then I'm going to select the glass and right click and assign the glass. Now, if I bring back the fish and we just frame on in again, and I render this, you're going to notice there is an issue. So the issue is we obviously cannot see the fish. And the reason why we can't see the fish is to do with one of the render settings. So let me open up the render settings again, and you can see down here we have ray depth. Now what ray depth does is it basically controls the number of kind of bounces that the ray does, and we want the ray to be able to bounce all the way through the glass, through any bubbles we have, through the water, and get out the other side, because if the ray doesn't reach the far side and out the other side of the fishbowl, we're going to end up with not having a full translucent look to what we're doing. So I happen to know that for everything in the scene, including the bubbles that we haven't shown yet, this refraction ray depth needs to be set to 10 or above. So I'm going to set it to 10 here, and that should be plenty. I could also say that I want the ray depth to be extra for the diffuse and for the glossy, so we get more ray bounces, and I can also say that I want the reflection to be higher as well. And obviously the reflection one is very easy to remember what that does. It's kind of when you have those two mirrors back to back, or kind of facing each other rather, and you get those kind of infinite bounces or reflections between each one, kind of ever increasing, so you end up with that kind of tunnel look in the mirrors. That's what this does. So the more you increase this, the more kind of bounces in those mirrors you get. So increasing this is going to just mean that we get 1 bounce and 2 bounces of the reflection. So now if I render this, we should now be able to see all the way through the fish tank and out the other side, which is in this instance black, but we can at least now see the fish. So let's shut down these and continue. So next up, we're going to open up the vegetation, and the vegetation consists of a couple of things. Firstly, we have this area here. So if I select this is the coral, so I'm going to open up fish tank and just choose all of the coral, and that's this kind of purpley look. And then in here we have this kind of weed, and the weed consists of a leaf. So I've got a leaf here, so just make sure we're definitely on that, and right click and assign. And then we also have the weed main, which in this instance both the weeds are called Kemp. So Kemp spline, that's kind of the main kind of spline, or I don't know what you'd call it, the branch of the plant. So that's that done. Vegetation is all done. We also have some bubbles. So if I select the bubbles, and let's just select off the background. So we just have the bubbles there. Again, I'm just going to come in and assign the bubbles there. And then finally, we have some stones at the bottom. So I'm going to select one, up arrows to select all of them, and then just go ahead and select the stone shader and apply that. So we've done bubbles, coral, the body of the fish, the eyes, the glass, eyes again, the water we've done, table, stones, the vegetation, and that should be everything. So if we now switch everything back on and move this into the middle, and again go for one more render, we now should have everything in place. Okay, so there's our scene rendered, and you can see we're getting a really nice result. So a couple of things just worth pointing out. Firstly, when you're dealing with opacity inside of Arnold, there's one additional thing that you have to do that you probably wouldn't expect you have to do. If I select my glass here, and I just go back to wireframe for a moment, you'll notice that in the attribute editor, under the shape of the object, so this is the object shape, we have this Arnold tab, and in here you have to turn off opaque. So when this is turned off, you then can actually have something fully transparent. Okay, so opaque needs to be off. If you leave it on, then you're not going to get true transparency through your object. Okay, so it doesn't matter whether you apply a kind of a glass shader or something like that, this still needs to be switched off at the kind of shape level of your scene. Okay, so that's really important to do. From here, let's come back and look at our render. And what we want to do now is we want to deal with some of the noise that we've got taking place in this. So again, let's just let this render to familiarize ourselves with what it looks like. Okay, I'm just going to save that out. So I'm going to keep that image. Let's come across to our render settings. And up here in this top section, samples, this is where all the magic happens. And this is really why Arnold is so nice, because to get a nice looking render, all we really need to contend with are these sliders. So let me very quickly explain how they work, because it may not be fully apparent straight off the bat. And if you're coming from something like V-Ray, the values that you use here are quite different in kind of numeric amount to what you would use in V-Ray. So the first thing to note is this number here, 1, is actually squared to give you your real sample number. So if I switch it to 2, this number is actually squared, so you're actually getting 4 samples. Now the nice thing is, up here above, you have this little readout that tells you what's going on. So we can see here that our camera AAs, or our main AAs, have a sample value of 4, which is 2 squared. We know that, that's great. Below that, we have diffuse, glossy, refraction, and subsurface scattering. Now the diffuse is obvious. This is the number of samples for the diffuse surface, or the diffuse render setting. We then have glossy, and this deals with what you would in a more traditional pipeline imagine to be the specular highlights, but in Arnold's terms it deals with both what you would imagine to be specular and reflection, so that all comes under glossy. Again, we'll go into much more detail on this later on. You then have refraction and subsurface scattering. These values down here are then times, having been squared, times by this value. Okay, so that's where it gets a little bit confusing. So if we have our diffuse samples at 2, we know that is squared, so that makes it 4. But then it's then times by the square number of the AAs up here. So we have 4 times by 4, which gives us obviously 16. And that's why it says the diffuse samples are 16. Okay, so this value is squared and then times by the square of the AAs. Obviously, again, next week as we get into the render settings, I'll go through this in more detail, and there's various ways that we can kind of help ourselves understand what's going on and make sure we don't get our samples too high. And this is where, if you're coming from, say, a V-Ray background and you're used to putting your samples up much higher, actually in reality keeping these quite low is what you want to do, because the fact that they're squared is actually giving you a high number of samples. So what we can look to do is we can first of all take our AA samples and let's increase those to 4. They're squared, so we're actually getting AA samples of 16. We could then, if we wanted to, just nudge up the diffuse, the glossy, the refraction and the subsurface scattering to 2. So 2 for each one of these is obviously 4, and then that's times by our 16. So you can see the diffuse, glossy, refraction and subsurface scattering, each one of those is actually 64, and that's then giving us a total count of 218 samples. So we're actually producing quite a lot of samples with these values. But if we now come in and render this, you're going to see a massive difference in the quality of this scene. So let's just click render and let that run through. Okay, so that's now gone through, and if we compare the two, you can see that we've really got rid of a lot of that noise. Now we may have even made the render longer than we needed simply by having too many samples. So I'm just going to drop my AA samples from 4 down to 3, which has made quite a big difference. And when we do our next render, we can see whether that is still giving us a clean image. Now there's one more area where we need to deal with samples. So let me just close this section. Let me grab my light again, which is obviously my sky dome. And if we scoot down here, you'll see that in this section at the bottom, or at least just below the main section, we also have samples. And again, these work the same way. So if I set this up to 2, then this is squared, so this becomes 4, and this is then times by the AA again. So this is probably not a bad number to set this to. And let's go ahead and do a render now, and that should just increase the quality of the kind of the light that we're getting in any shadows and things like that. Because you'll notice down here that we still have a little bit of noise in these shadows, and that's going to be then cleared up based on this value here. So again, I'm just going to come back here and again click render. Now remember, I've dropped my overall AA samples from 4 down to 3, so we may end up with a little bit more noise overall in our image, but we're going to get a quicker render time. Okay, so that's now rendered through, and even with lowering my AA samples, you can see here in my shadows we're getting a much nicer image. So again, if we just go between the two, you can see we have brought back a little bit of noise up here in dropping the AA samples, but we have also in bringing back some of that noise, we've also cleared up some of that noise down here in the shadows. So probably the best value for this scene is going to be having the AA set to 4. Everything else looks great, though we may now be able to get away with lowering some of these other values, and that's something that you're really going to have a play with to see whether that's going to be helpful. So I'm going to try dropping them and just seeing whether we get any noise coming in any of these areas. I'm going to leave the subsurface scattering as it is, just because we're getting a little bit of noise in here, so I'm going to make sure that that's still set to 2. Okay, so last thing we're going to do is we're going to make a camera. So I'm going to create camera and just go with the camera here. I'm going to go panels and look through my camera and then just frame up on this. Now if you're unaware, if you're in a position that you really like in your viewport, you can come up to view and then create camera from view. That's a new feature inside of Maya 2014. For the time being, I'm just going to leave my camera set somewhere like this. Also going to just check my resolution gate. That's what I'm going to be getting. Now I'm going to go to the 4 views, and I'm just going to frame in, and I'm going to work out making sure that I'm framing in on my on what I've got here. So Shift and F should frame in all my views at the same time. From my camera here in the top view, I'm just going to work out how far back my scene is. So let's just move back. There it is. I'm going to come to create measuring tool, distance tool. I'm going to go from the camera to, let's say, the middle of my fishbowl, and that's 15.4, near as done at 4, so 15.4. So switch this across to camera. In our camera settings, we're going to drop down to our Arnold tab. And in here, we can set the enable depth of field. And the focal distance we've said is about 17. We've then got the aperture size, which I'm just going to set to, let's say 6. Aperture blades, let's say we're going to have 5. A little bit of curvature, maybe 0.25, and we don't want any rotation. Everything else we're going to leave the same. We'll talk about things like rolling shutter and various other bits and pieces later in another class, but we'll leave all that as is, and if we now render our scene, we should begin to get a little bit of depth of field taking place. So I'm going to render this, and this will then be the end of the class. So let me just save this out just so we've got it. So I'm going to call this mini project, and I'm just going to call this end. So that's where we've got to before we pressed render. So I hope you've enjoyed the class. We've certainly gone through quite a lot of things, and hopefully you've now got a really good idea on a very kind of brief level as to how we can use Arnold to texture things, light things, and render them. So in the coming weeks, we're going to go over everything in a lot more detail. We're going to be looking at all the render settings, shaders, textures, lights, all the bits and pieces we've talked about in the outline. And hopefully by the end of the course, you're going to have a very, very good understanding of Arnold, the power of Arnold, and why you're going to want to use Arnold above many other render engines. So looking forward to any questions that you may have. Please put them in the forums. We will get to them as quick as possible, and look forward to next week with you. So until then, as always, this has been Matt Leonard for FX PhD.